Hey there. Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.
Hi, today in my bench I have this beautiful Denon amplifier. The model number of this unit, and by the way it is written in the back plate, it is a Pma-920. This unit came to me by a customer of mine, and from about a week from now he contacted me and he said that his amplifier has been stopped working and he wants me to take a look at it. So today in this video we are going to tear this unit down and see what's wrong with it and how we are going to fix it. A quick notification that this unit, it is not the first time came to me by this owner or this customer. From about 18 years from now, this has been came to me for repair, and it has been back in that time it has been into a lot of shops, and a lot of people they tried to fix it and they did not manage to get it up and running right. And as I remember, it took me about a month just to restore it, and it was in a really rough condition. So yeah. So without further ado, let me undo the screws of this cover and take a look outside and see how we are going to fix this unit. So here's the screws that they hold the plate or the cover to the body of the unit, and apparently from the looks of them they are not the original screws. I remember I used different type of screws, so yeah, so definitely someone was in it. As you can see, before I remove the cover, there is a lot of dirt and dust that it is in this unit apparently. So yeah. So let me pause this and remove the cover and we will see what we are dealing with. So here's the cover has been removed, and as you can see, wow, a lot of dust and dirt that it is inside of this unit. Wow, and a lot of rust. So yeah, this unit has been into hell. And someone apparently, where this, oh, this is the phono jack. So someone used silicone in order so he can secure it. So yes, so definitely someone has his time trying to fix it, and apparently it didn't work because it came to me. So yeah, anyway, taking a look at the fuses, apparently that someone has tested the fuses and see if they are blown or not, and someone did replace this relay, as you can see. So yeah, wow, a lot of work needed to be done in order so this unit can be fully operational, as I think, because wow. So what I'm going to do next, first thing I'm going to clean this unit up and remove all of this dust, and then we will power on the unit and see what we are going to deal with. So here's the unit has been cleaned up, and it is clean now about 80 to 85% at the most. So yeah, no matter how much I try to brush it and blow it up using the compressed air, I could not remove any more dirt and dust from it. So yeah, After a close inspection of the circuit, apparently someone did try to replace these transistors, and yeah, and this screw, it is different from the rest of the screws, and apparently there is a problem in the insulator or in the insulator, the silicon insulator of the transistors. As you can see, this one it is completely gone, and yeah, this one it is also gone. And also there is a corrosion issue, as you can see from the pins of this diode in here and in this resistor, and also this diode in here. So yeah, so this unit has a lot of problem, and as you can see, a huge amount of rust in this area. So wow, this unit has been into hell. So wow, a lot of work needed to be done in order so I can put back into a full working condition. So wow. Anyway, what I'm going to do now, I'm going to disconnect the power from the amplifier section and see and test the preamp circuit and see if it is going to work right or not. So yeah, I tried to find a copy of the service manual of this unit, and I was able to find one, but unfortunately it was all in Dutch. So yeah, but it is really handy when you are going to service this type of unit, regardless of the type of the language that it is written and printed in it. As you can see, once again, it is the Pma-920, and this is the unit. It is a Nippon Columbia collated, and if we take a look at the specs in here, we can see that it produces an 180 watt at 4 ohm, and at 8 ohm it produces a 105 watts per channel, and that is a lot. That is a really quite capable amplifier, and I believe it is suitable to be used in any kind of home, and you can even throw a party with a set of really high efficiency speakers. You can throw a party in your home or in your backyard. So yeah, this is a really type of a good amplifier. As you can see in here, here is the type of a list of sets that you can connect to this unit. As you can see, here is the turntable, here is the CD player, the tuner, video player, as you can see, and also a rail-to-rail tape player, and also a tape deck. So this thing, it is compatible with all type of audio. So yeah, audio units. Now let's scroll down a little bit. As you can see, here is a list of or instruction how you can disassemble it, as you can see, and here is the block diagram. Here is the specs of the parts. As you can see, the pin out, and they are using, as I remember, and as you can see in here, this type of photocoupler. I see the TLP 521-2. So yeah, and they are using as a signal input selector the TC 9152P. So yeah, this is a really cool type of signal control IC. And here is the pin out of the transistors with the part number of the transistors, and they're using, as I remember and as you can see in here, this type of transistor that it has a built-in resistors inside of it. So yeah, this is like the normal type of transistors, but it has a resistor built in, so you don't need an external resistors to control it. So yeah, and they are using also a lot of FETs. Yeah, here is the resistor and the component value, as you can see, and here is an X-ray pictures of the PC board and the layout. It is not a very good high resolution manual, but it is a very handy when you are going to fix one of these, because this type of amplifier, it has multiple kind of circuitry and multiple kind of adjustment inside of it. So yeah, and here is an exploded view of the unit, as you can see. Now there is different models for the United States and for Europe, and by the way, this is the Europe version because it has the voltage selector for 240 volts. So yeah, and here is the TC 9152, and here is the circuitry of it, as you can see in here. And if this camera will just focus, it has a phono input, the CD tuner, AWACS 1, AWACS 2, and also there is the tape recorder connections. Yeah, the signal processing in this unit, it is really good, and it is not cheap. So yeah, as I remember, this type of it has a very unique type of resistor in the tone control. It has a 5K, and this type of value you don't find it often in amplifiers, and there is 30K. So yeah, most of the tone control in amplifiers, you find the 100K and the 50K and even the 10K, but the 5K and the 30K pots, they are not quite common. Anyway, here is the I believe here is the regulator, transistor regulator circuit, and it is not very clear, but as you can see, it is about 16.8 maybe. Yes, 16.8 volts, positive and negative. And here is the amplifier circuitry. Now this type of amplifier, it is really unique. It is similar to all kind of amplifier, but it has a very curious input. It has a two type of input. There is the transistor input for the signal input, as you can see, and there is also a FET transistor input. So yeah, this is really curious type of design that the designers or the engineers they use. So yeah, and also if we scroll down a little bit, you can see that here is the TLP 521-2. So yeah, what this dual photocoupler IC, it controls the biasing, and as you can see, it is controlled by this op amp, and this op amp, it is connected to the input signal in parallel with the input signal of the FET. So yeah, so here is the signal after it came from the tone control and to the this equalizer input jack, and here is to the transistor, and this is also going the same type of signal. It is going to this op amp, and it is directly controlled control the biasing. So yeah, so this thing, it is designed, I believe it is designed in a really good way to prevent excessive clipping of the circuit. So yeah, really good amplifier. And once again, the operation the operational voltage, it is 56.2 volts plus and minus. So yeah, this is a really high type of voltage, and a message to anyone who has this type of amplifier and he doesn't have any kind of knowledge in electronics, or how he can deal with this type of voltage. If you have any kind of malfunction in this type of unit, you don't try to service it yourself, take it to a professional, because this type of amplifier, it has a very high and a lethal type of voltage. So yeah, as I said, it has multiple type of adjustment pots. So yeah, it is a very sensitive type of amplifier. Yeah, as we can see, yeah. In here, in this section, as we can see, every amplifier, the left amplifier and the right amplifier, it is fed by these fuses. So the voltages, they came and purified by these capacitors, filter capacitors, and every power rail, it has its own fuses. So yeah, this is fuse 1, fuse 2, fuse 3, fuse 4. So yeah, so what I'm going to do now, I'm going to disconnect these fuses and fire on the amplifier and test some voltages and see how it is and what it is type of work needed to be done in order so we can make this unit work again. So I removed the fuses from their places, and here is the fuses, and I noticed something, that these two fuses, and they are in this side over here, and they are what supply this amplifier section. One of them, it is blown, as you can see. So yeah, don't know if you can see it with the blurring of the camera, but yeah, it is blown. So yeah, the other one, it is seems okay, and all of the other fuses, the two other fuses, they are okay. So yeah, so let me connect some power to this unit and fire it up and see how it is going to behave and what type of voltages we are going to get. So here is the plug has been connected through my power limiting circuit, and here is the power switch has been pushed on, and oh, you heard it, the speaker protection relay, it has been kicked in. So yeah, so it is, there is no problem, I guess, in the circuit. Now, according to the manual, we should have a minus 16.8 volts and a plus 16.8 volts. And let me just adjust my chair a little bit. The first type of voltage we are going to check is the amplifier voltage, and here is one, as you can see. I don't know if you can see it. Let me just switch hands. Here we go. So here is my DMM, and it has been connected one probe to the chassis of the unit, and because it is a common ground. And yeah, and remember that the unit, it is operational. So yeah, as we can see, we have 55.1 volts. So yeah, this is normal. The other one, it is 55.2. Yeah, so it is also normal. It is normal that you have a voltage difference between the schematic uh, and the real testing about 1 volt or maybe 2 volts and the most. So yeah, sometimes even more, but this type of variation in voltage doesn't have too much effect on the operation of the amplifier. So yeah, maybe the filter capacitors are a little bit weak and dry out over time, but that is another story. After we do all of the testing, we will test the capacitor and see if they needed any kind of replacement or not. A lot of people they would go and replace them, but yeah, maybe I will do that later on. So here is one of the ICs, and this is one of the ICs of the signal, and this is the, by the way, that 2068. So we should have at pin 8 a 16.8 volts. As we can see, we have 17. It's too high. I would rather in this type of ICs, and because the maximum operation voltage it is 18 volt, it will be about 15.6 or maybe 15. So yeah. And as for the negative, as you can see, we have 17.170, so it is close to 17.2. So wow, this is very, very high. Anyway, but this type of voltage, it will work in it for now. I will leave it for now. As for the IC, the voltage, the signal input selector IC, the pin 24, it is the positive one. And as we can see, we have 15.4, and that is because it is the voltages, it is fed by these two diodes, as you can see. So here is the diode 1, as you can see, here's the 17 volts. So this is normal. And yeah, let's test the negative one, and we have minus 15.6. So yeah, it is okay. But the voltages, as we saw, it is a little bit high. It should be less than a volt. There is a 1 volt. It is supposed to be not less than 1 volt. So yeah. So I need to address the issue with these regulators. Maybe replace the diodes. As we saw earlier, there is some corrosion in these diodes. Maybe these diodes, they got a little bit affected by the corrosion. So yeah, I believe all of the voltages are correct, and all of the ICs looks normal. So let me connect this the amplifier to my signal generator and see what kind of signals that the op amp and the tone control are producing. So yeah. So I connected the my frequency generator to the input of this unit, to the CD input of this unit, and I also fired up my oscilloscope, as you can see, in order so we can see what type of signal that the input selector IC it is producing, and also we can test the op amp and how they control and they amplify the signal. So without further ado, let me fire it up. And here is the unit has been fired up, and I already connected my oscilloscope ground probe one of the studs in the or to the ground of the input jacks. And as we can see, if we take a look at the CD input, as we can see, and here is the oscilloscope. So here is the left channel, as we can see, and here is the right one. So it is okay. Let me select the CD. Input in the DC 9152, and according to the manual, this the pin number 13, it is one of the outputs. So here we go, and here is the oscilloscope. So here is the pin number 13. As you can see, we have a very clear signal, and here is pin 11 of the IC. We also have a very clean signal. So yeah, so let me go ahead and test the output of the op amp. And here is the, as we can see, there is nothing, because I will have to. So let me pause this video a little bit and attach the hook type to the probe of the oscilloscope, and we will go from there. So here is my oscilloscope probe has been hooked to the one of the output of the preamp driver circuit, and let's boost up the volume. As we can see, we have a dirty controls, but actually the input or the output of the op amp circuit, it is okay. So yeah, it is a really clean signal. We have dirty parts, that's a given, but we have a very clear signal, as you can see. Let's test the tone control. Yeah, and also we have the tone control parts, they are not clean. So yeah, so let me, and here is the treble. The bass, it is a lot dirtier than the treble. So yeah, and here is without the tone control. So yeah, once again, the volume key needed a lot of cleaning in order so he can control the signal very well. So here is the output, one of the outputs, and let me connect the other output. As we can see, here's the other output, and also the amplification of the preamp, it is a very, very clear. So yeah, I really like that. So yeah. So yeah, and strong too, really strong. Oh yeah. Wow. So obviously the op amp, it doesn't have any kind of problems in it, and the only problem that I could find so far, two problems actually. First of all, the voltage, the regulator voltages are a little bit high, needed to be lowered down, and we have dirty pots. Beside that, the op amp circuit, it is working and working really well. So yeah. So after we confirm that the preamp circuitry of this unit, it is working like it should be, and there is no problem in it except dirty controls. I unplug the power cord of this unit, and I also disconnect the probes of my test unit in order so I can turn the unit around and do a visual inspection of the parts and the component in the power amplifier circuitry, and to see if there is any faulty or corroded component in these two circuitry. And after a thorough examination, I found several mistakes and several problems has been done in these two circuitry. And I will start by counting the problems one by one. The first problem that I found, that whoever work and repair these two power amplifier circuitry, he replaced the transistors with a different transistor part number. So if we just zoom in a little bit, we can see that this transistor, it has the number of C3855, and according to the manual or the schematic, this is the correct part number that it is listed in the schematic. But we can see that whoever replaced these transistors, he did not replace them with the same part number. He used an equivalent, and this equivalent, it has a different specs than this one. So yeah, this is what happened to this circuitry or to this amplifier, and the same thing he did with this amplifier as well. Now the second thing that he did, he replaced the photocopier IC, and according to the manual or the schematic, this circuitry uses a the TLP 521-2. It is basically a photocopier IC, a dual photocopier IC in the same packaging, but as we can see, he replaced it with a single one, and he replaced it with the normal photocopier IC. It is the PC 817. And if we flip the camera and zoom in, we can see that this is the part that he used. So yeah, now I don't know if this IC, it is the equivalent of the original TLP 521, but I will have to look into it. So yeah, now when I examine the pins of the some of the transistors, I found that some of the transistors, like this guy over here and around it, there is a lot of corrosion in them. So yeah, and not only that, whoever worked on this amplifier, he replace and manipulate the value of some of the resistors in the input circuitry. So yeah, wow, this is a weird type of work has been done to this unit. So yeah, so what I'm going to do next, I will see if I can get access to the other side of the PC board and inspect the traces and see what kind of work has been done to these PC board. Now the cool thing about this model, that it has an access cover in the bottom of the unit, and it is held to the body of the unit by these screws from 3 corners, as you can see. So what I'm going to do now, I'm going to remove all of these screws, remove the cover, and take a look at the PCB of the power amplifier. So here is the access cover has been removed, and after I remove it we can view and we can examine the main PCB board that hold the signal input selector IC, and also the signal control switch, and also the preamp or half of the preamp circuitry, and also the regulator voltage regulator circuitry, and also the power amplifier circuitry. Now if we examine this section of the PC board, we can see that it is in a really good neck, and it is the pads and the circuitry in it, it is very clean. Now I repaired this from a long time ago. As I said, it is about 16 years if I wasn't mistaken, and it is still in a really good condition, as we can see. And here is the regulator circuit that I work on in the past, and it is still in a really good condition as I left it. But if we take a look at the power amplifier circuitry, we can see the amount of damage that it is occurred in it from the sloppy job and the unprofessional job that whoever worked on this, he did it. So yeah. So if we examine the traces, we can see a lot of peeled and removed or missing traces, a lot of scratching in the PCB itself, and a very sloppy soldering job. So yeah. So repairing this amplifier, it is going to be a very hard task, and especially in this kind of damage. So what I'm going to do next, I believe I will start the testing process by removing and testing all of the component in the power amplifier circuitry, and I will test all of the transistors, all of the component individually, and we will go from there.